Let's move on to the second part of the water cycle. Water carries nutrients, sediments, and pollutants from the continents to the oceans via surface runoff streams and rivers. These materials can be carried for thousands of miles on ocean currents. Now, water also carries atmospheric pollutants to the Earth's surface when they dissolve in falling rain or snow. I know it's very hard to perceive, right? Singapore does have snow, but just think of rain for now, okay? And if you experience snow next time in a foreign country, do remember what you learned in CM3261. Water carries atmospheric pollutants to the Earth's surface when they dissolve in falling snow. Now, the water cycle or the hydrologic cycle summarizes how water in the liquid, solid, the gaseous phase form flows through the environment. And as you know, the oceans are the main reservoir in the water cycle, holding 97% of all that on Earth, right? You know that fresh water are what we need, right? Human beings need and organisms need to survive. But that only accounts for less than 3%. And two-thirds of this amount, these 3%, are trapped in glaciers, snow fields, and ice caps. Means we can't eat ice, right? We can't just uh, your ice kacang every day, right? So only one-third of this 3% of the water in the world are fresh water available in liquid form. So less than 1% are forms that we can readily use. And that includes the groundwater, surface freshwater, and the rain from the atmospheric water vapor, right? We can't just say, oh, we are thirsty and then open our mouth and breathe in water vapor and thinking that we get hydrated. It doesn't work that way. So in the water cycle, we are going to talk about four parts. Number one, evaporation and transpiration. Two, precipitation runoff and surface water. Three, groundwater. And four, human impact on the water cycle. Now, firstly, let's look into evaporation and transpiration. Water moves from oceans, lakes, ponds, rivers, all these are water bodies, and the moist soil, right? The water moves into the atmosphere via evaporation, right? And these are speeded up by warm temperature, strong wind, and a greater degree of exposure. For example, if an area is locked, right, enclosed, the forests are converted into an agricultural or residential area. It would lose water more readily than a vegetated area, right? Because it's contained. Like water also enters the atmosphere via transpiration, which is the release of water vapor by plants. Plants, like humans, they also, in a way, uh, respire, right? Taking sugar, give off CO2. So they do give off CO2. Right? Through their leaves, on a smaller scale, water also enters the atmosphere when it evaporates from the surface of organisms through perspiration or sweating. You might think that only when you run or do sports you sweat, but as we walk, even right now as I'm talking, there's perspiration. It's rather hot these days, right? So besides perspirations, sweating, right, you have transpirations and evaporation. They act as the natural processes of distillation, as water escaping into the air as gas. Now, next, let's move on to the precipitation, runoff, and surface water. Now, water returns from an atmosphere to the Earth's surface as precipitation or rain, and when water vapor condenses and falls as rain or snow, the moisture might be taken up by plants and used by animals. Again, you might not be familiar with snow, but for some of us, you know what I mean. Now, much of this flows as runoff into streams, rivers, lakes, ponds, and oceans, the water bodies on our globe. Now, the amount of precipitation varies greatly from region to region, helping give rise to our planet's variety of biomes. Now, let's talk more about groundwater. Some precipitation and surface runoff water soaks down through soil and rocks and becomes groundwater, which is water found beneath layers of soil. Now, the groundwater recharges aquifers, which are sponge-like regions of rock and soil that are underground reservoirs of water. Not water under the bridge, but water underneath the rocks and soil. The upper limit for the groundwater held in an aquifer is referred to as the water table. So the aquifer can hold groundwater for a long period of time so that the water can be very ancient there. Now, in some cases, the groundwater takes hundreds and thousands of years to reach fully after being depleted. Right? It's not just being stored there, but there's always the movement of water beneath the rocks. The groundwater will become the surface water, right, when it measures from a springs or flows into the streams, rivers, lakes, or the oceans from a soil. Now, lastly, let's move on to the human impacts on the water cycle. The human activity affects every aspect of the water cycle, and here are some examples. You think of building a dam in rivers, it slows down the movement of the water from a land to the sea. And holding water in the reservoirs, right? That's deliberate move by human, and that increases the evaporation because that concentrates the amount of water in a particular zone. And it removes the natural vegetations by clear cutting and developing land, right? This increases the surface runoff because we're trying to set up a place for a reservoir. That's not natural. So what happens is when you have more surface runoff, right, that decreases the infiltration, right, and the transpiration, and it promotes soil erosion. The withdrawal of the surface water and the groundwater for agricultural industries and the domestic use, it deeply depletes the river, lakes, and streams and lowers the water table. And the emission of pollutants into the atmosphere then dissolve, right? And water droplet changes the chemical nature of precipitation. We have a bit of acidity inside the rainwater, probably about pH 6.7. So you have this change in chemical nature in precipitation, it will sabotage the natural distillation process that evaporation and transpiration provide. And the water shortages also has given rise to conflicts worldwide, in particular in the Middle East zone, in country X, right, somewhere in the Middle East. And that I want you to think a little bit more without brings us to the end of the water cycle. Cheers.